Hello and welcome to this International Society of Automation webinar. Now allow me to introduce Johan, an ICS Cybersecurity Advisor. Johan is an independent consultant specializing in industrial control systems and cybersecurity. During his career, Johan has designed ICS system architectures, created company standards and policies, implemented major ICS projects, supported ICS site engineers, and contributed to the design of several ICS products. Now, Johan, if you're ready, why don't we get started?
Okay. Hello, everyone. Today's topic is a quick start guide to the ISA IEC 62443 Global Automation Cybersecurity Standards. I've assumed that you're basically familiar with the basics of cybersecurity for information systems. What I'm going to talk about today is what's different for control systems and why do we need standards that are specific to control systems as opposed to just using the IT standards that are currently available. So first, I want to define what is an industrial automation and control system. I'm going to start from the bottom up and talk about the components that comprise a control system. We've separated them up into 4 different types: embedded devices like programmable logic controllers, field devices, host devices like workstations and servers, network devices like switches and routers, and software applications like HMI or Historian, that sort of thing. Components are used to build control systems, and control systems are the hardware and software components of an industrial automation and control system. Examples of control systems: distributed control systems, DCS, safety instrumented systems, SIS, and SCADA systems, supervisory control and data acquisition systems, are all examples of control systems. So the product suppliers develop control systems, and those products are used to create an automation solution. The automation solution is a specific implementation of a control system for a specific asset owner at a particular location. So that's the, if you will, the instantiation of a control system is the automation solution. And finally, the last term that we have is industrial automation and control system, and that's the collection of people and work processes like policies and procedures and technology, which together form the industrial automation and control system. So basically, you can think of the industrial automation control system it's the automation solution plus the security program that an asset owner has in place to manage that automation solution. And just a word about the term industrial. When the committee first started, most of the people that were involved were from process industries like oil and gas refining, chemicals, manufacturing, that sort of thing. And so the term that we used was industrial automation and control system to describe what we were talking about. But it has since become apparent that this set of standards is applicable across a lot of different industry sectors, a lot of different sectors. So I've seen it used in transportation industry, building automation and control systems, even medical devices have referenced the 62443 set of standards. So next, I'd like to talk about what are the differences between IT and industrial control systems. And this slide is perhaps the most important slide that I have in the deck. If you remember nothing else, remember why industrial control systems are different from IT systems. So the two use the same technologies. Windows technologies, TCP/IP networking are 2 examples that are both used in IT systems and the modern control system. But the control system needs to address additional considerations of the environmental protection and product integrity. There's consequences that are found when you do your risk assessment for an industrial control system. There's specific consequences that are usually not found in an IT type of risk assessment. So, for example, endangerment of public or employee safety or health, damage to the environment, damage to the equipment that's under control, loss of product integrity are usually not found in an IT risk assessment, but they are in a control systems risk assessment. So, that is really the fundamental difference between the two. In an IT system, you're protecting information. In a control system, it's a cyber-physical system, so you're protecting the physical world. There are other differences, including higher expectations of system availability, system integrity, the performance of the system, management of change, and equipment lifetime. Equipment lifetime is, in an IT system, is usually measured in years. For a control system, the equipment lifetime can be measured in decades. So quite a significant difference between those two. Some notable cybersecurity attacks on industrial control systems. I'm not going to go through the whole list, but since I'm going to pull out a few of the most significant ones. The first one is Stuxnet. I think most people have heard about Stuxnet. But it's significant because it was the first targeted attack on an industrial control systems. All of the previous attacks were aimed at IT systems and may have also affected control systems, but this was the first targeted attack on a control system. We have several of these attacks are ransomware attacks. In 2017, particularly, most of these are ransomware attacks. Another one that's pretty significant is the attack on the Ukrainian power grid. This was a coordinated attack. It not only attacked the industrial control system that was controlling the electric grid and damaged that control system, but it also there was an attack on the call-in support centers as well. So this was a coordinated attack, pretty significant. And more recently, in 2017, the Trisis attack was on a Saudi Arabian petrochemical facility. And that was very significant because it's the first time that a safety instrumented system was directly attacked. This was the target, and the objective was to disable the safety instrumented system, which could have had pretty significant impact if there had been a process demand. But fortunately, there was an error in the code that caused a safe shutdown of the facility, and that's why they discovered that there was a cybersecurity attack on that system. So pretty significant. It's worth it to go back and look at the Trisis example and understand exactly what happened there. There are two standards development organizations that are involved in developing the ISA and IEC 62443 standards. The first is the International Society of Automation, ISA. We're working also in collaboration with the International Electrotechnical Commission, IEC. Although the two organizations, they both publish the standards, the 62443 standards, the content is identical with the exception of a page or so of informative forward in the two documents, but the technical content is identical between the two standards. The standards organization is also working closely with the ISO organization, particularly the committee that's responsible for the 27,000 series of standards for information systems. So now describe a little bit about the 62443 series itself. They are arranged in 4 different tiers. The top tier is the general tier, so these are documents that apply to the entire series of standards. The next tier down is policies and procedures. So these are what we call process specs. They talk more about what are the processes that are needed to support a security program as opposed to the technology. And then the 3rd and 4th tiers are system and component respectively, and they define the technical requirements for the control systems. So here's the complete list of documents that are currently either published or in progress. You can see on the left-hand side the date that the documents were originally published. If there's an asterisk, then that means that the document is currently undergoing a revision or a first-time development if it hasn't already been published. There are 3 kinds of documents. There's IS, which is an international standard. There is TS, which is a technical specification. And you can think of a TS as it has requirements in it. It's not a recommendation document, it does have requirements in it, but it's not quite as mature as an international standard. So you can think of it as a pre-international standard. Those are the technical specifications. And then the last category is the technical report. And these are more geared towards the how-to. There are no requirements in a technical report, but it gives further guidance on how to use the set of standards. You can see that I've highlighted in red the core set of standards that are needed to secure an industrial control system. A core concept in the entire series is the risk management, that the processes and technical requirements that are needed to secure a system are based on risk. The first one is defining the security program that asset owners must follow. That's in Part 2-1. And by the way, when I say Part 2-1, if I go back to this earlier slide, the part is the tail end of the document number for the standard. So it may, for example, be ISA 62443-2-1. That means, I'm also calling that Part 2-1. So the risk assessment process is another core part of risk management that's defined in Part 3-2. We'll talk about zones and conduits in a few minutes, but one of the core parts of that is to partition the system into smaller zones, and you can think of a zone as a set of assets that share a common set of security requirements. The risk assessment determines what is the target security level for that zone, and there's also a requirement that there is a document that documents all of the security requirements. It can be part of another document. It doesn't have to be a standalone document, but you do want to document all of the cybersecurity requirements. The product security development lifecycle is defined in Part 4.1. A key part of that is threat modeling. And this is the development process that a product supplier would follow to create and deliver a component or a control system. Technical requirements for systems and components are in Parts 3.3 and 4.2. They are organized by security level, and they're also organized by foundational requirements. I'll talk about both in a little bit. And then finally, the automation solution lifecycle. That's for the instantiation of the control system at a particular owner and facility. And there's roles that are defined for an integration service provider, a maintenance service provider, and then in order to assess how well an automation solution is meeting the requirements, there is a standard Part 2-2 which defines how to do an assessment using a concept called security program rating. There's three principal roles that are defined in the standards. The asset owner, that's the individual organization that's accountable for the industrial automation and control system. This is the individual organization that basically approves the risk assessment and has the resources to implement all of the policies and procedures that have been defined as part of the industrial automation and control system. In the standard, the asset owner is also defined as the operator of the control system and the equipment that it controls. The next role is product supplier. It's the manufacturer of a hardware or a software product. And then service providers are providing services to the asset owner. And there's been two types of service providers that are defined. The first type is a system integrator. And this is the organization or group of people who takes products from the product supplier and instantiates them into an automation solution. And then the second type of service provider is a maintenance service provider that's providing services during the operation and maintenance phase. Remember that these are roles and not necessarily defining individuals. So an individual or an organization can have multiple roles. Security development lifecycle. It's used by the product supplier to create their products. The basic objectives there is to design a product that it's secure by design and secure by default. And it should be integrated with the overall product development lifecycle. And you can see the different elements there: security management, defining requirements, secure by design and implementation, testing of the product. It covers how to manage vulnerabilities in the product and updating the product and establishing a set of security guidelines that the product supplier should follow. Foundational requirements are used to organize the technical requirements in the standards. There are 7 of them. The first 2, identification and authentication control and use control, is commonly known in the IT world as access control, those first 2. The standard decided to split them out in order to manage the number of requirements. There's in access control is probably the largest number of technical requirements in the set of standards. System integrity, data confidentiality, restricting data flow, primarily through networks and network control points, timely response to events. These could be cybersecurity events or alarms and other events from the equipment under control. And finally, resource availability. So these are the 7 foundational requirements that are throughout the series. Talking about zones and conduits, I mentioned them a few minutes ago. A zone, it's a logical grouping of physical, informational, or application assets that share common security requirements. And a zone has a boundary between trusted and untrusted assets. So what's in the zone is trusted, What's outside of the zone is not trusted by that zone. There can be different types of zones. You can have physical zones, so you've got things like doors and with locks and that sort of thing. You also have network zones. So this is zoning is very similar to network segmentation as a concept. You can also have zones that are authentication zones. So a Windows domain, for example, would be an authentication zone. Conduits are the communication channels that connect two or more zones. It's a grouping of communication channels that also shares common security requirements. So this is where you would define, for example, confidentiality requirements, encryption requirements, connecting the different zones. It's how you define the restricting access for information coming into or out of a zone. There are some zone and conduit requirements that are defined. There are two that are shalls. That's separating business and control system assets, and also separating safety assets from other assets like control systems. So the standard does require that you separate your control and your safety and your business assets into different zones. There's also, you can create zones for temporarily connected devices like laptops or smartphones, that sort of thing. Wireless devices. You can separate devices that are connected to external networks. Those are recommendations, they're not requirements. And as I mentioned before, you can have logical and physical type of zones. And security is enforced by security measures at the boundary and inside the zone. So the common metaphor is you don't want to have M&Ms for your cybersecurity strategy that's hard on the outside and soft in the middle. You really want to go for a strategy that's more, you've got good boundary protection, but you also have good hardening of the devices that are within the zone. Essential functions is a concept that's somewhat unique to the 62443 series of standards. An essential function, it's a function or capability that's required to maintain health, safety, the environment, or the availability of the equipment under control. We break that into a couple of different concepts. One is protection, the other one is control, and the last one is view and manipulation of the equipment under control. So these are the things that you are trying to maintain. And the concept here is that security measures shall not adversely affect an essential function. For example, if you have a big red push button to shut down the process, if you have a software version of that, you wouldn't want to require a login before you can initiate the emergency shutdown function. That's essentially what we're talking about here for the essential functions. It does pose some constraints on system design. The first one is access controls shall not prevent the operation of essential functions. Essential functions shall be maintained, shall be local to the zone that they are in. So you can't rely on a service that is outside the zone for an essential function. And if there's a denial of service event on the network, it should also not prevent the safety functions from acting. So important, this is one of those things that separates and makes control systems unique and different from information systems. Here is a lifecycle view of the set of standards. There are two life cycles that are defined with tie points between the different life cycles. The first one is the product development life cycle. We've already talked about that a little bit with when we covered the security development life cycle. That's the life cycle that's used to design and create and deliver a component or a control system product. Then there's the automation solution life cycle, which is the life cycle of the instantiation of the control systems at a particular owner and facility. And that's broken into two phases. The first is an integration phase. You can think of this as the project development and phase for a control for an automation solution. And then the second is the operate and maintain phase, where you have things like patch management and other processes that are in place to maintain the industrial control system. You can see most of the standards are focused at either product development lifecycle or automation solution lifecycle, with the exception of the technical requirements for systems, Part 3-3, which spans both the product lifecycle and the integration lifecycle, integration phase of the automation solution lifecycle. Finally, we have a way to independently verify that products have met the requirements of the 62443 set of standards, and that's called the ISASecure certification schemes. There are three different types of ISASecure certifications. First one is Security Development Lifecycle, where this is a certification by an independent party that a product supplier has a security development lifecycle that meets the requirements of 62443. The second type is the System Security Assurance, and that's a certification by an independent body that certifies that a control system has met the requirements of Part 3-3. The technical has the technical capability to meet those requirements. And then the last one is CSA, Component Security Assurance. It certifies that the component device, either embedded device, host, network, or software application, that those have met the requirements of Part 4-2. So I've included here some resources for you to get smarter on the 62443 series. First of all, you can get the standards at isa.org, and the product certification, ISASecure. The link for that is isasecure.org. And ISA also offers training for cybersecurity. You can see there's the link there for the set of training courses that are available. And continuing on, there is a book that's been published on Security Process Hazards Analysis Review. That's PHA for consequence-based cybersecurity. As IEEE members, you get a 15% discount from that. There is also, this presentation was based on a guide, quick start guide, an overview of the 62443 series of standards that is currently being developed for the Global Cybersecurity Alliance. Should be out in a couple of weeks. And then finally, the homepage for ISA is isa.org. You can see some phone numbers and email addresses as well. If you want to get involved, the committee is always looking for new people to either draft documents or to review and comment on documents, or if you just want to stay up to date with what's going on, then you are able to do that. If you contact either one of those two phone numbers, we'll get you to the right place. So I'm ready for questions. there's any questions.
Okay, Johan, we do actually have a couple of questions for you. Johan, our first question asks, how would I use the ISA IEC 62443 for the Industrial Internet of Things?
So the standards do apply to the use case Industrial Internet of Things. There is a special working group within the committee that's currently developing a technical report, which is a how to use the 62443 standards for Industrial Internet of Things. But concepts like security zones, risk assessments, all of those, the trust models that we have, threat models, all of these things apply to that Industrial Internet of Things use case.
Our next one is that asks, does ISA align with the U.S. National Institute of Standards and Technology, their cybersecurity framework, and guidance on industrial control system security, and the American National Standards Institute standards on control system integration and security for industrial automation control systems?
Okay, good question. So yes, the ISA does align with both of those. The NIST framework, if you look at the NIST framework, you'll notice that there are, for each element, that there are references to other standards and practices for that element. And the ISA standard is referenced and included as part of that. So for every one of the NIST elements, you'll see an ISA 62443 reference as well. For the ANSI standards, so the ISA standards are, so ISA as an organization is an accredited organization for standards development by ANSI. And all of the ISA 62443 standards are also ANSI standards. So actually the full title would be ANSI/ISA-62443- part number. So yes, the ISA does align with both of those.
Our next attendee asks, are ISA IEC 62443 standards only used for industrial applications?
So I mentioned that earlier. Originally, the set of standards was developed for industrial applications, but because they were written in such a way that it was not sector specific, we have seen this set of standards used for other sectors, and the ones I'm familiar with, it's been used in medical devices, it's been used in the transportation sector, it's been used in the building automation and control systems sector as well. So those are the ones that I'm familiar with, but there may be others.
One of our attendees asks, is this applicable with an autonomous or remote-controlled vehicle system?
So that's a good question. I think that some of the concepts in the standards would be applicable to vehicle controls as well. I'm not sure that the standard, if we had any people that were involved in vehicles themselves involved in developing the standard, but certainly some of the concepts can be used. For example, within the vehicle, segmenting networks, doing the zone partitioning, all of those things are good security practices that would, I think, apply to vehicles as well. But it's not my area of expertise, so I can't really say. Okay,
so one of our attendees asks, how are you seeing the integration of OT methods from 62443 being adopted by IT organizations for use in hybrid applications like hospitals?
So again, I think many of the risk assessment and zoning concepts that are in 62443 would apply to these other use cases as well. again, I'm not a subject matter expert for hospitals, but you know, I would think that you would want to segregate different types of devices that share the same security requirements from others. I know I do have some experience with IT systems in my former organization. Started with a flat IT network and slowly moving to a network that has that is using more of the zoning concept as well. So yes, I do think some of the concepts in 62443 do apply to these other use cases.
Can you give an example of how a security measure is different for IT and IACS systems?
Yes, so let's take patch management, for example. In my experience, typically in the IT case, patch management, the patch is pushed centrally to all of the different workstations and servers that are on the network, and the end user is usually asked to restart their computer, and they're required to restart their computer within a certain time frame. That's my typical experience. In the process control world, or the control system world, there's a much higher level of management of change required, because if you restart a computer quite often, it's going to cause the equipment that it controls to stop as well. And in many cases, this equipment is intended to run 24/7, 365. In some cases, it might be years before there's a maintenance window that opens up. And so, you know, the management of change, there's usually a higher expectation on quality of the patch, additional testing that's required, for example, because unfortunately sometimes a security patch will break functionality, and that's not something that you want to have happen in a control system. So that's some examples, just using the patch management example of difference of approach. The objective is the same for both IT and ICS systems, but the method and the approach that's used is very different. Okay, one of our attendees asks, does ISA IEC 62443 apply to the nuclear industry, or is there a similar nuclear standard? So there is a working group that is in the ISA 99 committee that is looking at how does this set of standards apply to the nuclear industry. Again, I think many of the concepts apply to the nuclear industry, but you know, currently that working group is not very active. So I'd have to say it may apply at this point in time, but I can't really say that it should apply. It's also not one of my areas of expertise.
Can the SCADA software computer with Windows be automatically updated?
So by automatically updated, I'm going to assume that it's without intervention by a person in between, and it really depends on the application. But in general, I would have to say that this is an area that you would want to be cautious with. In my experience, most control systems, as I mentioned before, need a higher level of management of change. And although you can automatically deliver the patch to the system, the actual updating of it, you know, restarting the computer and restarting the applications, is usually not automated. Usually that's a manual process.
Is it possible to stop an attack before stopping PLCs, SCADAs, and networks?
I think the answer is yes, but I'm not sure. I think I need a little bit more context to that question. You know, usually PLCs, SCADA systems, networks, you want to be able to run 24/7, 365. So you try to avoid stopping the PLCs and SCADAs and networks. Many of the security measures that are put in place are intended to prevent an attack. But it's also important that if you are attacked, that you have an emergency response procedure in place to deal with that attack, and some of that might involve stopping the PLCs and the SCADA systems and networks and the associated equipment that's under control. But that's very dependent on the circumstances, dependent on the emergency response procedure for your particular facility.
Thank you, Johan. That was actually our last question, so we're going to wrap the webinar up right there. Thank you for presenting for us today, and to our audience members for spending some time with us. Take care, and we'll talk with you soon.